In 10.4, we are adding and subtracting radicals. In order to do that, your radicals have to be like radicals. They have to be the same, sort of like a common denominator. Whenever you're adding or subtracting fractions, you have to have the same denominator. And you just, once you do, you can add the numerators together. That's sort of, I guess, kind of the same thought behind it. So a like radical will have the same index and the same radicand, so the same root and the same inside. So square root of x and the cubed root of x are not like radicals. Square root of 6 and the square root of 6a are not like radicals because the inside of one is 6, the inside of the other is 6a. But on C, we have a square root on both, and we have x squared and y as our insides. So C has like radicals. So whenever we have like radicals, and you're adding and subtracting, you keep the radical of the root of 3 in this case, and you just say whatever the operation is, 8 plus 9 to give us 17 square roots of 3. So on number 3, you have the square root of x, and you're going to add 5 and 3 and subtract 2 from that to get 6 square roots of x. On number 4, you notice that we have the square root of 5 and the square root of 2. Both are square roots, but the insides aren't the same. So we cannot add this because it's not like radicals. And on number 5, you have the square root of 5 for each of your radicals, and you have 7 minus 9 minus what's right here. We'll just say 1 to give us negative 3 square roots of 5. So on these next few, at first glance, you would think, oh, these you can't add or subtract them because they are not like radicals. But whenever you're doing this, you should always try to simplify your radicals first. Now, the ones that we were just working, the radicals were already in their simplest form. Anyway, once we simplify these first, we may have like radicals. So let's look at number 6. Let's see, we're going to leave the 5 on the outside. And the square root of 12, let's write the prime factors of 12. 2 times 6, which is 2 times 3. 27 is 3 times 9, which is 3 times 3. So we have a group of 2 here and a group of 2 there. So I bring a 2 out and I bring a 3 out. So 5 times 2 is 10 square roots of 3. And that'll be 7 times 3, 21 square roots of 3. We now have like radicals. So we can say that it's square root of 3, 10 minus 21, so negative 11 square roots of 3. On number 7, this looks scary, right? Fractions. No reason to be scared. So 45, its prime factors are 5 times 9. 9 is 3 times 3. 80, let's see, we got 2 times 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. A 2 comes out, another 2 comes out, and you have the square root of 5. So let's talk about this multiplication first, because I want to, I do have like radicals now, but I do want to, simplify the multiplication in front of them. So 2/3 times 3, what happens is the 3 right here cancels with the 1 in the denominator. You're left with 2 square roots of 5. And with the 3/4, this 2 and this 2 multiply to give us 4. So that would cancel with the 4 in the denominator to leave you with 3 square roots of 5 for a final answer of 3 plus 2 is 5 square roots of 5. Number 8, I think, is our first one that has variables in it. 18 can be written as 2 times 9, which is 3 times 3. 8 is 2 times 4, which is 2 times 2. And then you have the x squared. Right here, the x squared, we have that, that x that will come outside of the radical. But we also know that by saying how many times does 2 go into 2, and it goes into there 1 time. And a 2 will come out as well. And then we already had the x that was in front. I didn't draw this to where it was too pretty, I'm sorry. And then right here, and we have 3x squared in the front already. A 3 comes out. And we have the square root of 2. So that's 9x squared, square roots of 2. And 2x squared, square roots of 2. Which we have the square root of 2. And then 9x squared plus 2x squared. I'm glad the 9x squared and the 2x squared are like terms, because that's why I can add those. And so we have 11x squared, square root of 2. On the square root of 14, square root of 14, that doesn't simplify, but it's okay because they're already like radicals on this one. So you got the square root of 14, and you got 1.2 minus 4.5 plus 2.1. So you just want to type all of that in your calculator, and you get negative 1.2 square roots of 14. And you're done with that. On number 10, we need to, again, make these like radicals. Remember, there's a couple ways to think about the root of a variable. You can say, how many times does 2 go into 7? And it goes into there 3 times. 2 times 3 is 6, and so there's 1 left over. So an n cubed comes out front with the 5. And you have the square root of n left, again, because 2 goes into 7 3 times with 1 left over. And now 2 goes into 3 once. So the n squared gets an n out there with it because 2 goes into 3 once with 1 left over. You could have written it out n times n times n times n times n times n times n for n to the 7th, and saw your 3 groups with 1 left over. And for n cubed, you could have written it out as 3 n's multiplied by each other with your 1 group and 1 left over. Anyway, we have 5n cubed square roots of n minus 8n cubed square roots of n. So this is square roots of n, 5n cubed minus 8n cubed, which gives us negative 3n cubed square roots of n. For number 11, 28 is 2 times 14, which is 2 times 7. 16 is 2 times 8, which is 2 times 4, which is 2 times 2. And 63, 3 times 21, which is 3 times 7. So right here, 2 can come out front, so you got 2 square roots of 7. Right here, 2 can come out front, and another 2 can come out front. Nothing would stay inside. And 2 times 2 times 2 is 8. on the end, a 3 can come out front, and a square root of 7 remains. So not everything in this is like radicals. Only the 2 square root of 7 and 3 square root of 7 are. So what I'll end up having is the square root of 7, and I'll say 2 minus 3, and then I'll tag plus 8 on the end to give me negative the square root of 7 plus 8, and I put negative the square root of 7 because 2 minus 3 is negative 1. I just didn't put the 1 right there with it. On number 12, you have like terms with the square root of a, and you'll just say negative 5 plus 9, and then you got the square root of b. So this would end up giving us negative 5 plus 9 is 4 square roots of a minus 4 square roots of b. And that's all we can do because the square root of a, the square root of b are not like radicals. They are both square roots, but their insides are not the same. And finally, for number 13, 3w24 is 2 times 12, which is 2 times 6, which is 2 times 3. And we have 9 and 2 times 3 times w. And 54 is 2 times 27, which is 3 times 9, which is 3 times 3, and you have that w on the end. So right here, 2 can come out front, and that will give us 6w. Square roots of 2 and 3 are left, so 6. And with the square root of 2 times 3 times w, nothing repeats, so I'll just have to say that's the square root of 6w. Nothing comes out front with that 9, so this one didn't really change at all. And then a 3 comes out front, so 3 square roots of 2 times 3 times w, so 6w. We don't have like radicals. I take that back. We do right here, but this one's not alike, so I will just copy paste that one back down, and I will say 9 minus 3 square roots of 6w to give us a final answer of 6w square roots of 6 plus 6 square roots of 6w.